Hello everyone, it's Mr. Miller here with a review on how to divide monomials. Unlike adding and subtracting, you do not require like terms in order to multiply and divide monomials. Here, we don't have like terms. We have 12m to the fifth n squared divided by 3m squared n. Let's write that in expanded form. And that's a bunch of m's. But it doesn't matter. Let's start by reducing our coefficients. We've got 12 over 3, and that gives us 4. So we're going to write down 4 as our coefficient to the answer. Now for the next step, we're going to divide constants. For our first step, we divide constants, and that quotient is the 4 in our answer. So next, we're going to begin by canceling m's from the bottom with m's from the top. 1, 2. We have m times n in the divisor, so we're going to cancel them both with m's in the dividend. We see that we have m times m times m remaining, which is the same as m cubed. So we can subtract the exponents to determine our variable's exponent in the answer. And from here, we're going to repeat the process with n's. Cancel the n in the divisor with the n in the dividend, and you're left with simply n. So when we go to subtract our exponents in our problem, we have to remember that a variable without an exponent is the same as a variable raised to the first power. And that's why we get n to the first power in our answer. Let's try another example. 24q to the 4th r to the 8th divided by 8q cubed r cubed. That was a tough one to say. Of course, when we're not 100% sure what to do, I'd always recommend writing everything out. So let's use expanded form. There we go. Again, we're going to start by simplifying our coefficients. 24 over 8 is the same thing as 3. So 3 is the coefficient in our answer. If we weren't writing this out in longhand, this part is the same. 24 divided by 8 gives us 3. Now let's cancel some q's. Start in the denominator and cancel 1, 2, and 3. We quickly realize we only have one q left in the numerator, so that q goes into our answer. Now when we look at our original problem, we can subtract the exponents for the q. Q to the 4th minus q to the 3rd equals q to the 1st. Easy peasy. Now let's go to the r's. Let's cancel. 1, 2, 3. And we're left with r times r times r times r times r, which is the same thing as r to the 5th. If we were calculating it using our base problem, we subtract our exponents for our r's, so 8th minus the 3rd gives us r to the 5th. Are you ready to try it without going to expanded form? Here we go. 16x to the 4th y cubed over 4x squared y. What do we do first? We're going to divide our coefficients. 16 divided by 4 is 4. What do we do next? Let's subtract our exponents for x. 4 minus 2 leaves us x to the 2nd power. And what do we do last? We subtract our exponents for y. Y to the 3rd minus y, which is the same as y to the 1st, gives us y squared. Our answer is 4x squared y squared. We're going to try one more example together. 16a cubed b to the 6th power over 4a squared. Now we see that there's a problem with our subtraction method. There aren't any b's to subtract, but we can pretend like we've got a b to the 0th power here, because that's like multiplying by 1, which doesn't change anything. Okay, so let's get started. Dividing our coefficients. 22 divided by 11 is 2. Next, what do we do? A cubed divided by a squared is, subtract your exponents, a to the 1st, which is a. And b to the 6th power divided by b to the 0th power is b to the 6th. We're going to come up on some practice problems here. Get ready to pause your video and try them yourself. Here they are. I'll start the countdown now. Okay, Here are the answers to your practice problems. Did you get them right? Did you remember to divide your coefficients and subtract the exponents of like bases? That's all for today. Don't forget you can call, email, or iMessage for help, and as always, I hope to see you in study hall sessions soon.